So Unit 4, probability, is actually Chapter 5 in the book, but this is Unit 4 material. So we are going to use the following information to answer questions 1 through 3. You have a bag with 6 blue marbles, 7 green marbles, and 3 red marbles. What is the probability of selecting a blue marble, replacing it? So this means doing it multiple times, which means this is going to be and probability. See the word and right there, which means a multiplication. And since we're replacing it, that means the denominator is not going to change. So we want to draw a blue marble first. So we have 6 blue marbles over the total. 6 plus 7 plus 3 gives us 16. And multiply, we want to draw a green marble. So 7 green marbles, and since we put it back, we still have all 16 marbles to deal with. So 6 times 7, we multiply straight across, is 42. 16 times 16 is 256. But we can reduce, the midterm is most likely going to have all those possible solutions in reduced form. So if you do 42 divided by 256 in your calculator, then hit enter, and then math, enter, enter, it will reduce the fraction for you. So you should get 21 over 128 as your final answer. Or 0.164. The midterm may have it in decimal form as well. It's going to switch back and forth, so just make sure you're okay with doing both. Number 2, what's the probability of selecting a blue marble and then a green marble without replacement? So we have the and, we're doing our experiment multiple times, so we're going to be multiplying. Here we're without replacement, which means our denominator is going to change. So first we want to draw a blue marble. There's 6 blue marbles out of the total 16. But then we don't put it back. So now we have only 15 total marbles to choose from, and we want to choose a green. All the green ones are still there because it's the blue one that we drew first. So this will be 7, but it's over 15 instead. Then we multiply straight across. We'll have 42 over 16 times 15 is 240. And then again, we can reduce the fraction, 42 divided by 240, and then math, enter, enter. That'll give us 7 over 40, or 0.175. So either one, again, be okay with both fractions and decimals. The answer choices will vary for the midterm. And number 3, last one with these marbles. What's the probability of selecting 2 blue marbles in a row without replacement? So 2 in a row, we're doing it multiple times. So that means it's going to be and, multiplication. Without replacement, our denominator is going to change. So first we have 6 blue marbles to choose from out of the 16 total, but then we draw a blue marble and don't put it back. So now we only have 5 blue marbles and 15 marbles total. So when we multiply straight across, we have 30 over 240. Can use our calculator to reduce. Gives us 1/8 or 0.125. All right, number 4. You toss a coin, what's the theoretical probability of getting a head? So theoretical, remember, is just based on the numbers what should happen. So when you flip a coin, there's 2 possible outcomes. You get heads or tails. So 2 is our denominator. And of those possible outcomes, only 1 would be heads. So it'd be 1 over 2, or 1/2, or 0.5. Number 5, based on the following results. So now whenever we're based on results, that means any numbers we get have to come from the results. We no longer care that coin flips are 50-50. We only care about the results of the experiment. So the experimental probability of getting tails, we got tails 1, 2, 3, 4, 5, 6, 7, 8, 9 times out of 20. We did 20 total, right? 1, 2, 3. Yeah. And so 9 over 20 would be the fraction. It's already reduced, or that would be 0.45 as a decimal. Number 6, when rolling a 6-sided die with the numbers 1 through 6, what is the probability of rolling an odd number? So here we're not giving any data, so that means we're just doing theoretical or classical probability. When we roll a die, we have 6 possible outcomes, so 6 is our denominator. Of those 6 outcomes, there are 3 odd numbers, 1, 3, or 5. So 3 would be our numerator, which can be reduced to 1/2, which would be 0.5. Number 7, rolling a 6-sided die with the numbers 1 through 6. What is, the probability of rolling a multiple of 5? So multiples are where you take that number, you can multiply, the answers you get when you multiply that number by something. So like 5 times 1 is 5, so 5 is a multiple. 5 times 2 is 10, so 10 is a multiple. 5 times 3 is 15, so 15 is a multiple, and etc. These are multiples. So when we're dealing with a die, though, we have 6 possible outcomes, and only one of them is a multiple of 5, because the dice only goes up to 6, and the next multiple is 10. So it'd just be 1 over 6. Which would be 0.167 as a decimal, and I think that was another typo in the answer key. This is a new review guide, so we're trial and error here. All right. Number 8. You draw a random card from a shuffled deck of cards. Find the probability that you draw the ace of spades. So we have 52 cards in a deck of cards. So 52 is going to be our denominator. Ace of spades, there's only one ace of spades. So you get 1 over 52. And if we want to do a decimal, it'd be 0.019. The probability of not getting a club. So there's 2 ways to do this. You can either do 1 minus the probability of a club, which would be using the complement, or if you just take the hearts, 13, plus the diamonds, there's 13, plus the spades, there's 13, divided by the total, 52. So it'd be 39 over 52. Which is reduced as much as it could be if we want to do a decimal. And then we'd have 0.75. All right, drawing a 2 or a 5 or an 8 or an ace. Okay, so we got or, so there's going to be all these adding. There's 4 2s out of 52. There's 4 5s out of 52. And then there's 4 8s out of 52. And then there's 4 aces. And then whenever we're adding, we always have to check to see if there's any overlap. Here, we're just talking about different values of the cards. So a card can't be a 2 and a 5 at the same time. So here, there's no overlap. So we'd have 16 over 52, which can be reduced to 4 over 13, which is 0.308. Okay, number D, or letter D. A heart or a red ace, so or means addition, which means we have to check for overlap. So if a card can be a heart and a red ace at the same time, yes it can, it's the ace of hearts, so there's 1 overlap. So with the hearts we have 13 of them, plus the red aces, there's 2 red aces, the ace of hearts and the ace of diamonds. Then we have to minus the overlap, so minus that ace of hearts, the 1 over 52. So that would give us 14 over 52, which can be reduced to 7 over 26, which would be 0.269. Okay. Letter E, we have an ace of hearts or a king. So again, we have or, so that's addition. We have to check for overlap. Can a card be the ace of hearts and a king at the same time? No, we can't. So that means we won't have anything to subtract. So the ace of hearts, there's only 1 of those, so 1 over 52. And then with a king, there's 4 kings, 1 of each suit. So we have 5 over 52, which as a decimal would be 0.096. Okay, for F, a red spade. So here, you do need to have some understanding of the cards, because the only red suits are hearts and diamonds. Spades are black. So a red spade is not a thing, which means this is impossible. So it has a probability of 0. And then G, a spade or a king. So or, again, addition. So we need to check if there's overlap. The king of spades overlaps. So we do our spades first. There's 13 of them. And then we have 4 kings, and then we minus the overlap of that king of spades. That would give us 16 over 52. Should be 4 over 13, or 0.308. Alright. Number 9, a bag contains 8 red marbles, 12 blue marbles, 17 green marbles. If one marble is randomly selected from the bag, what is the probability that the marble is red or green? So we're only doing our experiment one time, and we have or there, which means we're going to be adding. So we need to check to see if there's any overlap. can a marble be green and red at the same time? No, so we don't have to worry about subtracting anything. So if we're drawing a red marble, we have 8 reds over the total, 8 plus 12 plus 17, which is 37. Plus, because it's or, drawing a green marble, which is 17 over 37. So we'd have 25 over 37, which is answer choice C. And number 10, a circular spinner is divided into 5 equal parts. If the spinner is spun 3 times, what is the probability that an even number is spun all 3 times? So all 3 times, you're doing it multiple times, that means it's and probability. So we want an even, and an even, and an even. So into 5 parts, that means the even numbers are going to be 2 and 4. So we'll have 2 over 5, and means times. It's a spinner, so there's no with or without replacement. You're going to have all 5 parts to choose from every time. Times 2 over 5 times 2 over 5, which would be 8 over 125, which is D. Number 11, if you cannot be on the soccer team and the football team at the same time, that is an example of mutually exclusive. These are events that cannot happen at the same time. Remember, a complement is not, that not probability. That's that E with a little c. And we learned that the probability of E plus probability of its complement always has to equal 1. So just a reminder, a little tidbit there. 12, given the following probability distribution, what is the probability of x equals 3? So here, if you need to remember the rules of a probability distribution, which is that first you can't have any probabilities that are negative and you can't have any that are larger than 1. And the sum of all the probabilities in a distribution has to equal 1. So if we just take the probabilities that we know and subtract them from 1, whatever is left over will have to be that remaining probability. So you do 1 minus 0.12, minus 0.20, minus 0.03, minus 0.5. And we get 0.15, which is B. And that is it for Unit 4.